Hello everyone, this is Doc Fan. Let me ask you a question. How fast do you think you are moving right now? Your actual velocity could be much larger than 220 kilometers per second. And with this speed, you can travel from Tokyo to New York in less than a minute. How is this possible? Let's discuss it today. Alright, maybe you are watching my video on the sofa or on the bed. So you think your velocity is 0 meter per second. But pay attention here. Your reference is your room or maybe is ground. So this is your reference point. And with respect to this reference point, your velocity is 0 meter per second. But remember, your room and the ground are on Earth. But Earth itself is not stationary. Earth is spinning with respect to itself. So if we consider the rotation of Earth, because we are on Earth, so we have to move along with Earth. Let's just imagine there's a person on the equator. And due to the self-rotation of Earth, clearly this person is going through a circular motion. And from the knowledge we have learned for circular motion, the linear velocity v equals to 2 pi r divided by t. So if we consider the center of Earth as our reference point, so the center of Earth is our reference point, then this person here on the equator moving in a circle. And we know the radius of Earth is 6,371 kilometer, so which is the rotation radius. And we know the period, which is very simple, basically 24 hours. So if we substitute the radius and the period into this equation, we can get the linear velocity of this person on the equator, which is roughly 460 meter per second. So while this person may be sitting on the sofa, or maybe he's lying on the bed, he is actually moving 460 meter per second along with the rotation of Earth. Of course, depending on your position on Earth, your rotation speed might be different. For example, if you are on North America, then your rotation radius would be smaller than the radius of Earth. And how do we find this velocity? Which is very straightforward. This velocity at a certain altitude equals to the velocity on the equator times cosine theta. And theta is the altitude here. Okay? So clearly you can see that for Santa on North Pole, Santa seems to be stationary because Santa is on the rotation axis, so Santa is not spinning. So do you think Santa is stationary? The answer is no. Why? Because besides the self-rotation of Earth, Earth is also orbiting with respect to Sun. We know Earth orbits about Sun in an ellipse, but for our calculation, we simplify this. We just consider Earth orbits about Sun in a circle. Then we can get the linear velocity, or you can say the orbiting velocity of Earth with respect to Sun. And since we live on Earth, so while Earth is orbiting, we are orbiting together with Earth. So we are actually having the same orbiting velocity as Earth. We know the distance between Earth and the Sun is roughly 1.496 times 10 to the power of 11 meter, and we know it takes Earth 365 days to finish one revolution with respect to Sun. So in other words, we know the period is 365 days. Then, based on this, we can see if we consider Sun as our reference point, we can get the orbiting velocity of Earth, which is also our velocity because we live on Earth. If we substitute the rotation radius and period, we can get the orbiting velocity of Earth is roughly 30 km per second. So how fast is this speed? Just imagine you are traveling from Paris to Berlin. So if you are traveling with this speed, you can finish the whole trip less than 1 minute. This is how fast you are. You think that's it? That is our velocity, 30 km per second. We are actually moving much faster than that. Why? Because consider the whole solar system. It is also orbiting around the center of our galaxy, which is Milky Way. So we can simplify and consider that the Sun orbits about the center of galaxy in a circular path. So the linear velocity of our solar system, or you can see the speed the solar system orbits with respect to the center of our galaxy is 2 pi r divided by t. And since Earth and us are in the solar system, so we are moving along with our solar system with this speed. In this case, our reference point is center of Milky Way. And we know the distance of our solar system to the center of Milky Way, so the rotation radius is 2.53 times 10 to the power of 20 meter. And we also know how long does it take for the solar system to complete one revolution, which is basically the period. And this period is super long. It is 230 million years. And if we substitute the radius and the period into our equation, we can get the velocity of the solar system with respect to the center of Milky Way is roughly 220 km per second. If we put this velocity into perspective, if you travel with this speed from New York to Tokyo, it will take only less than 1 minute. This is how fast the solar system is orbiting about the center of our galaxy. And this is our velocity if the reference frame is the center of Milky Way. And basically now you get my point, right? If you consider our galaxy in the reference frame of universe, you would imagine our velocity would actually be much larger. And you are right. So from what we discussed today, you realize the importance of reference frame, right? So if we consider the room or ground as our reference, our velocity is 0. But if we consider the center of Earth as our reference point, our velocity is about 460 meters per second. But if we consider Sun as our reference point, our velocity is about 30 km per second. But if we consider the center of our galaxy as our reference frame, our velocity is about 220 km per second. Some students may say, what if I consider a certain point on the universe? Can my velocity reach infinity? This is actually a very important question, and many top physicists debated for a very long time until one guy, his name is Albert Einstein, he gave the best answer, and his answer is the speed of an object cannot reach infinity, and actually there is an upper limit, and we will have to discuss that in a separate video. Thank you for your attention. I will see you next time.